Welcome grade 7 to another one of our math videos. In this one we're taking a look at perimeter and area, but not of a particular shape, but more of what we call a composite shape. So that is what happens when we join together some of the shapes that we've already learned about. So we're going to be taking the information and knowledge that we've gathered about squares, rectangles, triangles, circles, parallelograms, and trapezoids, and bringing all of that knowledge together to solve some particular questions. So what I would say is, if you need to, feel free to break out that formula sheet that hopefully you've been creating. If not, you might have to go through and try to remind yourself about some of these formulas as we step through these particular questions. That's it in terms of a lesson. There's nothing new that we're learning. We're just bringing these concepts together. The big thing is going to be stepping through the example questions so that we can understand how best to do that. This is one that I would probably highly recommend you stick around for. If you'd like, you can take a look at the example pictures on your own and do the try-its on your own, but it would probably be very helpful to stick around for listening to how to solve some of these particular composite shapes, as they can be a little bit tricky and daunting if you don't know where to start. So let's step through our examples. We're going to be going through starting with example 9. We have 3 examples to go through. Example 9, 10, and 11, which are going to pair with try-it 9, 10, and 11 as well. So example 9, we are given a shape that looks something like this. We're given some information about the shape. We have a dotted line here as well. We are told that this distance is 3, that this distance is 5, that this side is 4, and that this height is 6. So really, our first step when we're going through solving this question would be to try to see, well, what shapes do I really have here to work with? And when I'm looking at this particular shape, I see, this is a right angle, by the way, I see 2 main shapes here. I see a triangle right here, and I see a trapezoid right here. And so I'm going to separate those into those 2 shapes and figure out the area of those individually and then piece them together when I'm done. So if I were to break those apart, I would end up with a shape that looks like this, which is my trapezoid, 5, 4, and 6, and a shape that looks like this, which is my triangle of 6 and 3. Let's solve those separately. So trapezoid, remember that our area equals 1/2 times base 1 plus base 2 times height. So 1/2 times our base 1 is going to be this here. You can use this as your base 1 or this is your base 1, doesn't matter. I'm going to say this is our base 1 though. We don't have this and this because they're not parallel. So we have to use our 2 parallel sides as our bases. So 6 plus 4, our 2 parallel sides, times our perpendicular height, which is 5. So area equals 1/2 times 6 plus 4 is 10, times 5. 1/2 of, or 1/2 times 10 is 5, times 5, or an area for the trapezoid of 25. Now, we're going to put that in the back of our minds for a minute. We're going to get to our triangle now. Remember that our formula for a triangle is base times height divided by 2, or 1/2 base times height. Our base is 3. Our height is 6 divided by 2. Area equals 3 times 6 is 18. Area equals 9. Now all that's left to do is to put these 2 together, to add these 2. So 25, the area of the trapezoid, plus 9, the area of the triangle, is going to give me a final area of this quadrilateral of 34, and then because of the units they give us in inches squared, because it's area. So this composite shape, it was a little bit complex at first. in the way that it looked, but once we identified that it was both a trapezoid and a triangle, it went a little bit easier in figuring out how to solve that particular question. Example number 10, let's go on to that one. We may need more than just the space that we have here, as it is quite an interesting shape. We have a line here, a line here, a line coming up here, and then we have a circle on top, or at least half a circle. We're given a line here as well, a dotted line. We're given a dotted line here. We're told that this whole distance is 24. We are told that this perpendicular height is 12. We are told that this side height is 13. And then we have to just go from there. So first things first, this is broken up into multiple parts. Part A asks us to find the perimeter. Generally, perimeter is easy. We just add up all the sides. And we can start to do that. We can say that this is 13. So I'm going to say 13 plus, this is 24. 24 plus, this is going to be the same as this. So they're the same. So plus another 13 plus the circumference. So plus 1/2 of the circumference of this circle. Okay, so to go any further with this, we need to figure out the circumference of this whole circle and then just take half of it for the very top there. Getting a little bit tricky already. Remember that for the circumference of a circle, circumference equals pi d, or pi times diameter. I don't have diameter, but actually I sort of do. The diameter is the distance from here to here, all the way across the circle. And I know that this is 24, so this has to be 24. So circumference is actually pi times 24. And again, you could plug this into your calculator in multiple different ways. I'm just using 3.14. And when I do, I get a circumference of 75.36. So I'm going to plug that in here. I actually need half of that because I only have half of a circle circumference. So that half of that would be 37.68. So now I have 13 plus 24 plus 13 plus 37.68, which when I plug all of that into my calculator, it gives me a perimeter of roughly 87.68 for that particular question. So that one took a long time to figure it out. If you want, the question actually says you can leave your answer in terms of pi. I didn't in this example, but you could in solving that particular question too. Solving it in terms of pi would just mean that when we get to here, this would be 12 pi, and then we'd add the rest of this stuff to it in order to get an answer of something like 12 pi plus 50. 50 would be all of these pieces added together. So two ways to solve this question, either 87.68 or this answer here. B asks us to figure out now the area of the figure. Okay, well, the area of the figure, we have two here. We have a parallelogram, and we have a circle, but half of it. So half of a circle and a parallelogram. So let's figure them out separately and then piece them together. A parallelogram, remember, the area is just simply base times perpendicular height. So the area of that parallelogram is going to be 24 times 12. And when I plug that into my calculator, it gives me an area of 288. Now the circle is a little bit trickier. This one also says we can leave it in terms of pi. Pi r squared. I just figured out my last one that my diameter is 24. So if my diameter is 24, my radius is half of that, or 12. So pi 12 squared, or pi 144 pi. All I have to do is add these together. And if I didn't solve for pi, then I would have something like 144 pi plus 288 would be, or sorry, I have to take half of that for that. So I take that divided by 2. So I would have 72 pi plus 288 as my final area of this shape. To figure out what that would actually be, all I'd have to do is take 72 times 3.14, which is 226.08, and then add that to 288, which would give me a total area of about 514.08 for this particular composite shape. So pretty tricky as we step through, but as soon as we start identifying what the shapes are, it helps us to plug away. It's kind of like chipping away, taking a big granite block and starting to chip away pieces in order to see the beautiful statue that's inside that it's going to become. That's what some of these math questions are more like. Chipping away at what we know to figure out what we don't. Example 11. Example 11, the final example here. It gives us a shape that looks like this. Do my best to draw it here. We are told that this is 6, that this perpendicular height is 4, that this is another 3, and that this total is 8. We're also told that this line and this line are parallel. So this says the figure represents a billboard in which we have these given measurements, and we're asked to figure out the area. So in this particular question, what we really have is a bit of an interesting one. Instead of having two shapes together, we actually have kind of a trapezoid shape here minus a triangle that's kind of taken out of it. So we're going to figure out the area of the trapezoid and the area of the triangle and then subtract them. Take the triangle area away from the trapezoid area. So let's figure these out separately first. So area of a trapezoid, remember that area equals 1/2 times base 1 plus base 2 times height. So area equals 1/2 times base 1. It doesn't matter whether we use this or this as our base 1. Let's just say that our 8 is our base 1, so 8 plus our base 2 is 6 times our height. Now height here is going to be this and this together. So 4 plus 3 is going to give us a total height of 7. So our area equals 1/2 times 8 plus 6 is 14 times 7. 1/2 of 14, or 1/2 times 14, is 7. And 7 times 7 is 49. So the whole shape of this trapezoid is 49. But now we have a bite taken out by this triangle. So let's figure out what that is so we can subtract it away. So this triangle here, remember that the area of a triangle equals base times height divided by 2. We have a base, a long base here of 8 and a height of 3 divided by 2. So our area here is going to be 24 divided by 2, or 12. Now that we have these two bits of information, the only thing left to do is subtract them. So we take the whole area of that trapezoid minus the area of the triangle that was taken out, and we figure out then that we have a total area of this shaded billboard section of 37, and because its unit is in feet, feet squared. So that would be how we would take two different shapes, a composite figure. We would take what we know about trapezoids and triangles in order to figure out what this odd-shaped area would eventually end up being. Hopefully that helps you as you step through the try-its. Remember that try-it 9 matches with example 9, try-it 10 with example 10, and try-it 11 with example 11.